So hello friends, welcome back to our channel STM Mechatronics. In this video we will see how to read from the SPI memory. So in the last video we have seen that how we can write the data at the SPI memory using SPI protocol. The data that we write, we have observed the logic waveforms, right? How the data has been written. Then we have gone through the data sheet. We have seen which register commands are used for what purpose, right? We have seen the opcodes. Now in this video we will see the necessary opcodes required for the read operation, then how we are reading the data, right? So in the last video we have seen we have written the STM Mechatronics in embedded simulations and the some random data from particular memory locations. So in the last video that I have also explained that there was a bug in our code. Okay, so we have removed that bug and we were writing from some random memory locations, and the data is correctly getting written into the next page. Okay, so now we will see how we are reading data from any random memory location, and we want to write the data that we have read into some another locations. So that we will start, and in the meanwhile what we will do is we will erase the data that we have read from memory location, or we have written to the memory locations. So what I want to do is right, so this is our memory, right? Our data is here, some data is here, these memory locations are empty, right? This is empty. Then here data is available. Right, so the data is already present over here. We want to read this data and we want to copy this data right into this memory location. Okay, then like we want to continuously test this, right? So what we will do is we will erase this data again. After writing it, we will verify the data that we have read is correctly coming or not in our simulation. Okay, by keeping it on hold, right? Or pausing the simulation, we will check the memory data. Then we will perform the sector erase operation. So after that we will again check these data, these memory locations, then we will again read, and then we will again write the data. Okay, so first we will do what we will do is now we will go here, we will modify our code, right? In the last video we have seen that we are writing the data from FF location, right? We are writing the data from FF location, it is getting written into the next page, that is correct. Okay, now like we have given some delay, then we are writing again, we are erasing the sector, we are writing from the FF delay, right? Now what we want to do is we will go over here, we will check in the SPI flash, okay, both the SPI flash.c and .h files. Okay, so the sector size is of 65536 bytes. Okay, that means 64 KB sector size, and the page size is of 256 bytes only. So whenever we are giving the command to erase the sector, right, from starting from memory location we have given that, so it will erase the sector which contains this address, whole address. So it will erase total 65536 bytes. Okay, now what we will do is we need to write our data, or the data is already written over here. We will read from this address, and then we will write at some another address. Okay, so first thing we will do is we will modify this address. So calculator programmer 65536, this address belongs to 10000. Okay, so we'll write data at address 1000000. Okay, now we need to check that our device contains this address or not. Yeah, so it is available. It is possible to write the data. Let's stop this. What we will do is we'll just we'll comment out this code. We'll build the code. Okay, so 0 errors, 4 warnings, and today's date is 13 December 2024. Right, now we'll go into our simulation. We'll load the file 13 December. Okay, click on OK. Then we will write the data. So first 8 seconds are for chip erase operation. There are total 8 sectors, so for each sector it takes around 1 second of time. That's why it will take total 8 seconds. Now the data has been written. Okay, we'll stop the simulation. We'll check that this data is erased. Right, data at sector 1 has been erased. I will go to address 100. Yeah, so 10000. Right, so here you can see that starting from address 10000, like our data is getting written. Right, now what we will do is we will read from this address and we will write into first sector. Now what we will do is we will read from address, read memory data. Right, we will give some delay. Read memory data from this address 10000. Right, now what we will do is like we want to read first 500 bytes. Okay, let's so our buffer address buffer or our character array is of 1000 bytes. Right, so we will read only 500 bytes. Then we will store those 500 bytes into this array, and then we will write the same data into the memory location. Okay, so what we will do is we will go over here, we will copy these 2 lines. Okay, we'll copy these 2 lines. Then we'll start writing from 00. Okay, now what we want to do is we want to write this same data that we have already read. Right, and we want to only write the 500 bytes of data. So we only want to write the 500 bytes of data. Okay, so for your clarifications, we have initialized our read data array as a null 0. So the contents of the array if you see, those are 0. Okay, so there is no data present over in the array. We will compile the code. So our warnings has been reduced from 4 to 3 only. Okay, now we'll see all these things have been done perfectly. Now what we will do is after this we will erase the sector. So we will erase the sector. Okay, sector 00, because we want to erase this sector. Right, then given this address, I'll walk you through this function read memory and write memory. we have already gone through this write memory function, but for we'll go through it briefly. Okay. Let's stop it. Right. We have already built our code. We'll build it once more. Now the time, if you see, the timing is 1:10 p.m. right. First chip erase operation, it takes approximately 8 seconds of time. Here you can see the timing. Okay, the chip erase operation has been performed. Now the write operations has been performed. We will pause the simulation. We'll go to address 10000. Okay, so go to address 10000. It's not going to that address. So yes, here we can see our data is already written. Okay, then what we will do is we'll go here. So yes, here you can see that our data is getting written, right. So first 500 bytes of data, those are getting written over here. Okay, so you can see this data is getting over correctly. The data that we have written at the address 10000, it is getting correctly written at this memory location 000000. Okay, this is a real-time simulation, so I'm not tampering the code. You can go through the code, you can replicate the code as it is and run the simulations. You will definitely get the results. Okay, so from here you can see that we have correctly read the code. Okay. Now after this we are performing the sector erase operation. So you can see that all the data that we have written it from starting from memory location 0000, it has been erased. Okay, yeah, so I guess there are some errors that we are seeing. So instead of reading FF, it is reading as 7F 7F. So I need to check this, but yeah, we'll walk through the code. We will check what is the issue over there, and we'll try to resolve it in this video also. So that yes, there is a bug in the read memory operation also. Okay, so we'll check the read memory operation. Now to read the memory, we have certain opcodes, right? So there is IDSR, read status register and write status registers. Okay, now to read the data, right, to read the memory, we have to send 0x03 first. Okay, and to write the memory we have to send 0x02. Okay, and for sector erase we have this opcode 52H. Okay, now keep this in mind that we have to send 0x03 for reading the operation. Now see, we have used the same opcode over here. Okay, and then we are copying this opcode into the local variable text data. This is 8-bit variable. Okay, now coming to over here, we have 24 bits of memory address. Okay, so we have divided whatever memory address that we have into 8-bit chunks. Okay, so byte chunks we have already divided into the memory address. Now what we are doing is we want to read certain length of data so we want to read particular number of particular bytes of data, right? In our case we are reading 500 bytes of data from the particular memory location. So until that data is read correctly, or until 500 bytes are read correctly, until 500 bytes are read, till that time we have to continue this loop. Okay, so what we have done is, while the data length is not equals to 0, right, we are reading the data. Now coming to the memory address modulo bytes per page is not equals to 0. Okay, so the memory address that we have provided over here divided by bytes per page. So whatever the remainder is, if it is not equals to 0, then what we will do is bytes to read is equals to bytes per page, that is 256, minus memory address modulo bytes per page. Now what it will do is basically it will give the bytes to read as 256 minus the memory address that we have provided is 65536, right, modulo 256. So basically this will give us 0, right, because 65536 divided by 256, right, it gives us 256, an exact number 256. So the remainder is 0. Okay, so if I do like this, 256 into 256 into 256, it will give us 65536. So the remainder is 0 over here. So 256 minus 0 is equals to 256. So in the first iteration we will be reading 256 bytes of data, right, because the starting address is the start address of the sector, new sector. Okay, so we'll read 256 byte in the first iteration, then we'll skip this else loop because we have already gone in the if loop. Okay, now coming over here, data length. So this data length will be reduced by 256 bytes because we will be reading 256 bytes in first by giving one read command. Okay, now what we are doing is we are providing the memory address. Okay, so the 24 bytes of 24 bits of data, that is 3 byte of data, has been divided into 3 different bytes. Okay, by the shift and add operation. Okay, now we are using the chip enable. We are sending the data as text data. Now this data is the opcode. Instruction opcode we are sending. Okay, instruction opcode, right, read instruction opcode we are sending. Okay, now after doing that we have to send the memory address. Okay, once we do that, these are send operations, right, we are sending the data. Now we will go into this, right, we are sending that pointer, that is our data opcode, and data length is of 1 byte, right. So if you go back, we can see that we are sending only 1 byte. and while we are sending the memory address, we are only sending the 3 bytes of data. So going into instruction, right? So for instruction opcode, the data length will be of 1 byte. Okay, the loop count is 0. Loop count is less than data length, that is of 1 byte. It is true, so it will go into the for loop, right? Now data shift is 80, right? So we want to send the MSB first, that's why we have written the inner for loop. Okay, so we are shifting the inner for loop 8 times, then we are sending the bits data from MSB to LSB. Okay, so that we have done. Then we are incrementing the pointer basically. So this pointer belongs to this register. Okay, now coming over here, coming back, so this iteration for instruction opcode will run only for one time. Okay, now it will come out of this loop. For memory it will run for 3 times. Okay, now we'll come back over here. Okay, now we'll go into the read data operation. So in the read data operation, we want to read 500 bytes of data, right? In the main code we have seen that we are reading only 500 bytes of data first. Okay, so data length will be of 500 bytes. Now we are sending the pointer data, that where we want to store the data that we have read. Okay, so for the read data operation, what we are doing is, like, if the loop count is less than the data length, right, so it will continue to iterate, continue to execute the for loop. Now same, the inner for loop will be running for 8 times. Okay, so what it will do is, it will read the MSB first, then it will read the LSB, right? Then it will means it will read bit 7, it will read bit 6, it will read bit 5, and it will, after reading the each bit, it will continue to store the bit. Okay, now once that is done, like, it will store the bits, and that whatever the data is there, right, it will write into the pointer data. Okay, so yes, so I know we have got our issue, that we are doing, what we are doing is, we are doing this wrong, right? So we were taking uint8 as a data shift register, right? Now we have assigned it value as 0. Okay, then yeah, so making this from uint8 to uint16, it will resolve our problem. So the data that we were reading as a 7f, it will instead, it will get properly read as ff. Okay, now this is simple operation. Okay, go over here, we'll stop the code, we'll start execution. Right, so first thing, it is erased. Okay, so every data that has been erased properly, we'll check at the address, right, this address. So every data has been erased properly. Okay, now we'll go at the address 1000, our data has been written correctly. Okay, so here after this last CC bytes, right, the data is 00 ff, right? Now we want to continue with this operation. Now this data was getting copied at the 0th location, right? So we'll go, so yes, like, our data is getting copied. Now we'll see. Yes, so from memory location 0000 our data is getting copied properly. And if you can see here, like after 5C bytes, right, we are getting 00 and we are getting the FF data correctly written. Okay, so yes, now we will walk through the whole code for once. Okay, now we have already seen this read device ID. What we are doing is, right, we are getting the opcode read device ID, then we are enabling the chip. So from high to low transaction on the chip select line, right, and after completing the operation we are again raising the chip select line to logic 1. Okay, so in chip select line, if you go in the chip select line, we are pulling it down. Okay, we are pulling it down to logic low. We are pulling it down to logic 0, that we are setting it to logic 0. Okay, then coming back, then we are sending the opcode of 1 byte. Then we are sending the read data, that is device ID. Device ID is of 2 bytes. Okay, then we are sending the chip select, we are making it as disable, so we are raising the chip select to logic 1. Okay, then whatever the device ID it is there, right, read device ID, we are right shifting it by 8. Okay, then we are making it and then we are returning it from the function itself. Okay, read device ID function itself. Okay, now coming over here, send data. For send data, that we are using it into multiple functions. For send data, again we are taking data shifter register as 8080. Okay, then what we are doing is, whatever data length we want to send, right, for that we have written the outside for loop. Okay, this block will run, this for loop will, outside for loop will run for the data length. So or the loop count becomes equals to the data length. So the loop count starts from the 0 till that it becomes to the data length, it will run. Okay, now again for transmitting each bit in 1 byte of data, okay, we are running this inner for loop, and then we are setting or resetting the pin based on the bit that we want to send. Okay, so first bit number 7 will be sent. Okay, then we are shifting this data shift bit, so bit number 6 will be sent, then bit number 5, bit number 4, bit number 3, bit number 2, bit number 1, and in the last bit number 0, that is LSB, will be sent. Okay, so this is send data function. Now coming to the read data function. In the read data function, we are using the same logic, that whatever data we want to read, so this loop, for loop, outer for loop will continue to execute till this loop count variable becomes equals to the data length. Okay, and after each iteration it will increment by 1. Okay, so the data shift bit, that this bit is already set to 0 in each iteration. Okay, now for the to read 1 byte of data, we are using this inner for loop. So 1 byte of data becomes 8 bits, right? To read 8 bits, we are running this for loop, inner for loop 8 times. That is, yes, 8 times, right? Now we are reading the pin, that is data out pin. So that is data out pin from the memory IC, right? Then we are giving the clock. Whatever data bit is there, we are reading it and we are storing it. Okay, so after completing this, we are just shifting it by 1. Okay, then after reading the complete data, we are storing it in the pointer given. Okay, now for SPI clock, SPI clock is basically toggling of the particular pin, clock pin, from high to low. Okay, and giving certain delay. Now chip select, chip disable, these are simple logics. Device operation enable is again simple logic, but we are not using it for right now. Write enable, okay, for write enable there is a special opcode that belongs to 006, that is already mentioned in the datasheet. We have already gone through the datasheets, or you can find the datasheet in the link section below. Okay, so we are enabling the chip select pin, or we are enabling the device, okay, by pulling the chip select pin to low, logic low. Okay, then we will send the data, that is opcode, and then we will again pull back the chip select pin. Okay, this way we are enabling the write operation, write enable operation. For write disable operation, there is another opcode 0x04. Okay, again we are sending the send mechanism again is again same, that we are enabling the chip select, that is driving the chip select pin to logic low. We are sending the opcode, and then we are driving the chip select pin to logic 1. Okay, now read memory, we have already gone through this read memory functions right now. Okay, so it is simple. The number of data length that we want to read, the while loop will execute till the data length becomes 0. In each iteration we will read the page we will read the whole page data from the memory address. Okay, memory address given. So if the memory address is last page address of the last page address. Okay, okay, so I'll correct. So if the memory address provided is in the last of the page, okay, so the number of bytes read will be only of 1. So that logic is implemented over here, how many bytes of data we want to read from the particular page. Okay, that operation is done over here. Okay, so the memory address modulus bytes per page, that is 256. If it is not equals to 0, how many bytes we want to read, it will be calculated over here. Okay, so 256 minus memory address modulus 256 bytes. Okay, this will give us the number of bytes to read from the particular page. Else, okay, if the memory address modulus bytes per page is not equals to 0, that means we are starting the memory address provided is start of the page, new page. So the data length is greater than the bytes per page, means the remaining data that we want to read is greater than 256 bytes. Then what we will do, we will read 256 bytes in one iteration, then we will provide again the memory address. Okay, and then we will again read the next 256 bytes of data or remaining bytes of data. Okay, so in such way we are performing this operation. Again, after completing that, like we are sending the chip select enable, we are sending the read instruction opcode, then we are sending the memory address, and then we are reading the number of bytes that we want to read, and we are storing that number of data into the pointer. Okay, pointer registers. Then we are selecting the chip select. Okay, then like once we have read the first 256 bytes from the particular memory address, or if like in our case we were reading from address 10000, so that was the start of the new page. Okay, so this memory address will be incremented by the bytes that we have read, the number of bytes that we have read. So we can provide any random memory address, it will read till the page end, then it will increment the memory address so that it can start reading the next data from the next new page. Okay, then same goes for the pointer data. Okay, now we have read one page data, now we want to store the next page data, right? So for that we are already incrementing the pointer. Okay, write memory data is again same, instead of reading we are sending the data, basically we are sending the data. So only this operation, right, if you check both the functions, only this operation is different, that say here it is send data and here it is read data, rest of the functionality is same. Okay, so we can combine these two functions also, and we can check that if it is write memory, write memory, we can use this. If it is read memory, we can use that. Okay. Then sector erase is again same. We are sending the opcode. Okay, we are enabling the chip select, right? We are making write enable, we are making the chip enable, we are sending the opcode, we are sending the memory address, because chip sector erase belongs to particular memory address that we want to erase the sector. Okay, so that is chip sector erase. And chip erase, we don't have to give any particular memory address, because it start erasing the data from the start of the chip, that is start of the memory address, that is from the location 0000 till the end of the all these memory locations. Okay, so this way we can implement our read write functionality, read write chip erase, sector erase, read data, read status register, write status registers. All this functionality we have successfully implemented in this video. Okay, so if you have any doubt, you can ask me. Okay, like I will be always able to available to answer your questions. So if you see here, right, this is 1 1, that is 6 write enable operation, right? After that we are sending the write instruction this way. Okay, so how we are writing, reading, all these instructions have been provided here. Okay, so I guess this is read instruction, we can see that, or this is a write instruction. Okay, this is 2. Okay, 1 2 3 4 5 6 7 8. So this is opcode 0x02. If we check opcode 0x02, that means program. So this is write instruction. Okay, that means we are writing the data. Now write enable, if you see write data, yes, so if you see write data, this is we are sending the write enable, right? Then again chip enable we are doing, then we are sending the write opcode, that is opcode program. Okay, then we are sending the memory address. Now the memory address is of 3 bytes, so we are writing it from 0x000000, right? So 1 2 3 4 5 6 7 8. Okay, then again coming to the 1 2 3 4 5 6 7 8. So it is giving the next page address. Okay, this is writing as 1, so it is 100. It started writing from 100. Okay, so then again 1 2 3 4 5 6 7 8. So 0 0 0 0 0 0 1 0 0. Okay, so it is writing from here. That's why you can see that this data has been changed. Okay, now our first data, that is at memory address 00, that is 62, right? So we'll check that 0001 0002. So if we can see that we are writing 62, that 0110, this becomes 6, 0010, this becomes 2. So if you can see that memory address 100, we have already written 62. Okay, so likewise you can already you can check this whole data. Okay, so in such way we have completed our read write operations, and we have completed our memory interface with the SPI memory IC. So if you like my explanations, if you found it interesting, please click on like, share with your friends, and subscribe to our channel. Thanks for watching our video. We will see you in the next video. Thank you.